Hello everybody, it's Mr. Boseday here. I am going to record a quick little video for you guys, wrapping up the video and wrapping up the lab we did yesterday. And then I'm going to use it to introduce an equation, and then I'll do an example problem, and then I'm going to ask you to do the rest of the problems on the page. So we'll quickly wrap up this page 9 and 10 with the lab we did yesterday, and then I'll do problem 1 on page 11, and I'll ask you guys to do the rest during your day. All right, so what we found in our lab is when we changed the voltage and we measured the current, we found that we got a linear graph here. And so that means there is a direct relationship between current and voltage, okay? Then later on in the lab, we swapped our resistors in and out, and we found that when we did that, as the resistance increased, the current decreased. So we found an inverse relationship here. So there was an inverse relationship there. And so what that means is that in both labs, we changed something and we measured the current, right? So we changed voltage and measured the current, and then we changed resistance and measured the current. And so what we can say is the result of that lab is that we got an equation in words that said this: current, electrical current, is equal to voltage, because there was a direct relationship between current and voltage, over resistance, because there was an inverse relationship between current and resistance. So that's how we got this equation. We call this equation Ohm's law, okay? Now, we have some unusual symbols for some of these things. For example, the symbol for current is the letter I. So it's a little bizarre, but you just need to know that and be aware of it. So the way we would write this equation in symbols is I equals V over R. So the V and the R are pretty straightforward, V for voltage and R for resistance. But like I said, it's just a little awkward. You just need to know that I represents current. We've mentioned the units of these things in class a little, but I want to make sure that you know them for sure. So we measure current in amps, and we usually use a capital A to represent amps. We measure voltage in volts, so that's no big deal. And we use a capital V to represent volts. And we measure resistance, and this is the most unusual one, in something that we call ohms. And the symbol that we use to represent ohms is the Greek symbol omega. Let's try that again. One more try. That's a little better. And so there you go. So when you see a problem that has something measured in these units here, you know it's representing resistance. Obviously, if something's measured in volts, you know that represents volts. And if something's measured in amps, you know that represents current. Okay? So let's do one problem together on page 11, and then you can do the rest. So problem 1 says a remote control uses a standard AAA battery. And if you didn't know, a AAA battery produces 1.5 volts. How much resistance is in the circuit if it creates a current of 2 amps? All right, so here we go. Let's use our equation, which is I current equals V voltage over R resistance. Let's see, we know that the voltage is 1.5 volts. So let's see, and the current is 2 amps. So we've got 2 equals 1.5 over R. And that's our goal. We want to find out the resistance. So what we're going to do, and this is a good example of some algebra, because of my unknown is in the denominator, first thing I want to do is I want to multiply it to the other side so I get it out of the denominator. So I'm going to multiply R over there. So I'm going to get R times 2. Let's do it down here. So I'm going to get R times 2 equals 1.5. Now, to get that unknown resistance all alone, I'm going to divide the 2 over. All right, so there's just some algebra reminders. So I get R is equal to 1.5 over 2. And when I plug that in my calculator, I get, I think, 0.75, but I'm just going to quickly make sure that I'm right about 1.5 divided by 2 is exactly. So the resistance for problem 1 is 0.75. And let's make sure we remember our units. And as I said earlier, the units for resistance are omega. So it looks like that. And there you go. That is the answer to number 1. If you want to see a really good example of the symbol omega, there it is right there. Okay? Looks pretty similar. All right, the rest of your assignment for today is to finish the rest of this page and then submit it to me on the Canvas assignment. I hope that goes well, and I hope you enjoy your day. I hope you're able to get through your schoolwork relatively quickly and then spend some time having fun. All right, I'll see you tomorrow. Bye, everyone.